सर
Yes.
हेलो सर, गुड मॉर्निंग सर. सॉरी लेट हो गई सर.
No, not an issue. हम स्टार्ट ही कर रहे हैं. दर्शन से हम थोड़ा
ओके ओके ठीक है.
Okay, so starting from scratch. This was electrostatic potential difference. If you still remember. Do you remember
यस
that?
सर.
Okay.
Yes, sir.
और इसमें स्टोरी क्या था, कुछ याद है?
Bringing the point charge
To bring
from
the point
R
charge from R
from
to P.
R to P.
Okay. From
R to P और फिर हम इन्फिनिटी ले लेते हैं P पॉइंट R को.
okay. Hold on. Okay. Today's वो जो था हमने डिस्कस लास्ट टाइम किया था वो था पोटेंशियल एनर्जी डिफरेंस. And today's topic is electrostatic potential energy. Okay. And what we have discussed last time was this diagram in which we shifted Q from R to P. Right? Now let
Yes,
me
sir.
share my video with you. Okay. So in that case, this was Q, this was location R, this was location P, and we shifted Q from R to P, and it landed somewhere at distance R. Okay. Potential here we took as UR, here we had taken as UP. It was found that UP was greater than UR. So we had a formula UP minus UR equal to negative
WPR.
integration E dot TR, or say F external dot TR. So this is F electric dot TR, R to P. But if I consider R to be at infinity, far away, now will there be an interaction of charge here at infinity and your source charge here? What is distance? Infinite?
Yes.
And if it is
Yes,
infinite, what is force between Q and capital Q?
Zero.
Zero. On what account you can say it is zero?
Because the distance is infinite.
Because formula was F equal to K Q Q upon R square. If R is very large, large square is very large, then answer becomes zero. So in a language of physics, we'll say interaction is zero. There is no interaction, so potential energy is zero, and that means U are equal to zero. So now W, instead of R to P, we write infinite to P. Work done to bring Q from infinity to P equal to potential at P minus potential at R, but R is at infinity. Same way, this R is replaced with infinite. Now this infinity to P, we simplify as WP. And this U infinite is made zero. Understood why it is zero?
Yes, sir.
Yeah.
Yes, sir.
Okay.
Yes, sir.
So,
Yes,
this,
sir.
so now we have got a more simplified version. Infinity to P F electric dot dr, if it is there, it is electrostatic potential energy. Is it clear?
Yes, sir.
Yes, sir.
So if you are writing UP minus UR, then it is potential energy difference. This is potential difference. Okay, and this is now what we have derived is just potential energy, and you can verbalize it like this: work done by external force
By
or
external
opposite to the
force.
electric force in bringing the
Force.
charge Q from infinity to given one. Okay,
Okay.
unit is joule. Work done, so unit has to be
So from point A.
Is it fine?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So now if I repeat, we had electrostatic potential energy difference. We completed electrostatic potential energy. And now electrostatic potential. See, three words in sequence: energy difference, energy, and potential. So this is new topic right now. We start with the previous one. Okay. What is meaning of UP?
Potential energy at P.
At P. Potential energy at P. What is meaning of this
Point
sign?
integration
Integration.
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 from infinity to P.
Infinity to P. So what do you mean by infinity to P? What you are doing?
This is infinity, and the on the upper side it is potential.
No, this P doesn't stand for potential. You are bringing charge
Yes.
Q from infinity to point P.
To P.
Okay.
Okay.
What is this?
Force of
Electric
Force
force.
of the electric force.
of
Electric force, and dr is small
Electric-
displacement. What is the meaning of this whole integration symbol and all other terms together? What it means? Potential energy at
potential.
Remember which word I'm using? Potential energy at P. It is work
P.
done to bring charge Q from infinity to point P. Now, those who are joining today might not be knowing or might be knowing electric field was defined as force per unit charge. So if F
Yes,
is
sir.
made subject, it is Q times E. Okay. So this is written instead of F electric, it is written QE. That's it. QE dot dr. Are you okay with that?
Yes,
Yes,
sir.
sir.
ठीक है दर्शन. Your wish is granted. Okay. Now here this formula has one issue. If this is potential energy at P, it depends upon charge Q. It also depends upon electric field. Now this creates a situation where dependence makes the situation clumsy. We want a simpler version. So what we do, divide this equation. Let's divide above equation by Q. Why? So can we get rid of dependence on?
Charge.
You get it?
Charge.
Because you want to get rid of Q. So what's the way out? Divide whole equation by Q.
Divide by Q.
So
Divide by Q.
this is what we have done
Divided
here.
Yes,
Both
sir.
side divided
Yes.
by Q.
Both the side divided by Q. Now this is UP by Q. We call it potential. Remember, UP was potential energy and UP by Q is just potential,
potential.
right?
Okay.
So what is the difference? Can you tell me now before I scroll down? What is the difference between this equation, this equation which is there on your screen, and this equation which earlier we derived this equation?
इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी के लिए है और वो यूनिट चार्ज के लिए है.
If I write it in my notebook, it was been like that. UP was negative infinity to P F electric dot dr, which later on we had written negative infinity to P Q E dot dr, and this was potential energy.
Energy.
What we did now, I'm writing as Vp equal to negative infinity to P just E dot dr,
E dot Q तो
right?
डिवाइड हो गया ना.
So now I'm saying this is potential. My question is, what is difference between these two?
It is for unit charge and it is potential energy.
This is for any charge which you are bringing from infinity to P, whereas this is for unit charge
Unit charge.
only. So when you're dealing with unit charge, you use the word potential.
Potential.
And when it is any other charge, we use the word potential energy. Is it fine?
Yes, sir.
This is definition.
Work done by.
Yeah, I have underlined unit because that is important.
ऐसा तो gravitational.
Yeah, it is somewhat similar to gravitational potential energy and gravitational potential. Quite similar. And this is the beauty of physics. The way you deal with gravity at microscopic world, or rather a larger world, and same way you deal with microscopic world also. In altogether different branch of physics, but still rules are same.
Formula ही different है.
Who is coming in? This is big. One EW. Some say some. I'm removing it because name is weird. I'm not letting him in. Okay, we move on to the next one. Electrostatic potential due to a point charge. This wording, do you find similar to one of the topic of first chapter? Upasna, you mute your mic.
Yes, yeah.
Yeah.
I'm listening.
Okay. There was one topic, electric field due to a point charge in chapter 1. Now we have
Yes.
got electrostatic potential due to a point charge. Okay.
Okay.
And before we proceed further, I want you to recollect. Do you know this
Last year's formula.
integration 1 by x square dx, and I was been telling that learn this, we'll need it in the next higher standard also. So what is answer
Yes.
of integration 1 by x square dx? So especially for biogroup students, I'm repeating, so pay attention. So 1 by x square can be written as x raised to minus 2. Now we had this rule of integration. If you got integration of x raised to n dx, you can write x raised to n plus 1 divided by n plus 1. So this is n minus 2 is n plus 1 divided by again minus 2 plus 1. So this becomes minus 2 plus 1. So it is minus 1. And denominator also minus 1.
Minus 1.
Okay. So this becomes minus 1 by x. And you should be okay with that.
Okay.
Okay. Why I'm
Okay,
teaching
sir.
this, soon you will realize. Okay. Okay. So back to what we wanted to do. Now you'll be paying a little more attention. We had a charge. What is the charge now we are dealing with? Is it Q
Point
or
charge.
1 coulomb charge?
Hmm.
Is it 1 coulomb charge or Q coulomb charge which we are bringing in?
Q coulomb charge.
It, see, I have highlighted potential only. Is it potential energy or potential?
It is only
Potential.
potential charge.
तो
It is
पोटेंशियल में कौन
potential.
सा चार्ज लाना पड़ेगा? यूनिट पॉजिटिव चार्ज लाना
Unit
पड़ेगा.
charge.
Unit positive charge.
So what is
Unit
here?
positive.
यूनिट पॉजिटिव चार्ज. इंफिनिटी से लेके p डैश से लेकर के you will bring it to p. Work done to bring unit positive charge from infinity to p is called potential. Remember, if you understood the definition, then your problems are solved. So initially it was at infinity. Somewhere when you started seeing it, it was at r dash, and the journey was finished at r. Fine. Is the definition clear to you? Then only I'll proceed further.
Yes, sir.
Okay. Now from definition of potential, potential at P is equal to work done to bring unit positive charge from infinity to P against T. This is the previous version only repeated here.
Okay.
Okay. It means we need to calculate work first. अगर वर्क फाइंड कर लेंगे तो आंसर आ जाएगा. उसके लिए चार्ज ट्रैवल्स फ्रॉम इंफिनिटी टू p डैश एंड p डैश टू p. ना मान लो कि चार्ज q was at p डैश. I'll go little fast. Okay. Charge q was somewhere in halfway mark at p dash at distance r dash and moved by little amount dr dash. So what is work done? dw, small amount of work done, F electric dot dr dash. Is it clear to you?
Yes,
Yes,
sir.
sir.
Okay. Now F electric and dr dash both are opposite. I didn't show here. Electric field will be going rightward and your charge is moving leftward. So angle is 180 degree or pi. So it is cos 180. Cos 180 is minus 1. There is minus sign here. Okay. Again, instead of F electric, I can write QE.
Okay, sir.
Okay. And instead of QE, I can write E.
E.
Because Q equal to 1.
1.
So dW equal to negative E dot dr dash. Fine.
Okay.
But we are interested in total work done, so we integrate from infinity to R. Work done, small amount of work done dW, and this is total work done. E dr dash as it is, and this is work done per unit charge. Remember what is we did? Work done per unit charge, we call it V.
Equal to V.
So instead of W, we are having advantage to write V because what we calculate is work done to bring unit charge from infinity to R. Okay.
Sir, is it conservative?
Yeah, electric field is conservative field.
Now work done.
Work done is conservative. So that's why gravitational field is called conservative field. Okay. We'll discuss that part. Now instead of E, can I write KQ by R square?
Yes,
Chapter
sir.
1. Why I'm writing R dash?
Because sir, that it different.
Because ये यहाँ से हम इस वक्त यहाँ पर है. So your 1 coulomb charge is right now at this point P dash and distance involved is R dash. Okay. So KQ being constant goes outside. 1 by R dash square is there. Right? And then straight away I'm writing minus 1 by R dash. So you are in which state out of this? Sad smiley or happy smiley?
Happy smiley, sir.
Happy
smiley. Okay. So now it is infinity. Lower limit is infinity. Upper limit is R. Infinity to R. Negative will become positive. The rest of the story is same. Now put down the limit. This should be R dash. Okay, here there is a mistake here. 1 divided by R dash. So when you put upper limit, it is 1 by r minus 1 divided by lower limit. Now, you know what is 1 by infinity?
0.
0 plus.
Okay, so what is left is kq by r.
R.
An important point, V is varying as 1 by r.
R.
And remember, electric field was varying as 1 by r square.
R square.
Yes.
Okay,
Hmm.
somebody is joining in. Hila. Okay, now what is relation between V and U? And that should summarize everything. V stands for potential and U for potential energy. So I'm writing two columns. One is for charge, another for work done. If I bring you 1 coulomb charge from infinity to P, work done is called V, according to definition, right?
Yes,
Yes,
sir.
sir.
Now, if you are bringing any other charge, what is work done? It is Q times P.
UV.
That is potential energy.
U is equal to Q.
UV, okay.
So U is potential energy and V is potential. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now, do I need to revise?
No, sir.
No, sir.
We are still left with 7 minutes extra. How come? Okay. Who is joining in? Okay, so recording भेज देंगे. ठीक है.
Yes, sir.
Yes, sir.
Okay.
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 Now we'll go further. Still, we are left with around 6 minutes. So pay attention. Notebook. Okay. So this new topic is electric potential at a point due to a dipole. Okay. Again, do you know this is somewhat similar to one of the questions that we did in chapter 1?
Yes, sir.
Instead of this, there was
Field.
electric field,
Electric field.
Hmm.
right?
Yes.
Yes, sir.
Okay. So dipole, say this is plus Q, this is minus Q. What it forms?
2L.
Distance between them is 2A or 2L, whatever you prefer. Now this arrangement is called electric dipole. Okay. Do you know what is
Yes,
dipole
sir.
moment?
Yes.
Yes, sir.
Yes,
E
sir.
equal to 2AQ
2Q.
2QL.
2AQ. Okay. This is called dipole moment.
Distance.
Now back to question. You have to find at a point. So let's say this is that point P where we want to find potential. So this distance involved is, let's say, R plus, and this distance is R minus. This is 2A. Okay, sir?
Yes, sir.
Yes,
Yes,
sir.
sir.
What find potential at P? I write Vp. It can be written as K
Yeah.
KQ by R.
Q. Let's say this is Q1. So KQ plus
By
divided by R plus
R plus.
plus K
2A.
Q minus divided by R minus. See, potential has one advantage, that this is scalar. So you can write this potential due to positive charge. This is potential due to negative.
नेगेटिव चार्ज,
So this is
नेगेटिव पॉजिटिव.
so this is K plus Q upon R plus
2r हो गया
K
सर, क्योंकि
minus Q upon R minus. This distance we have to take into account. R plus for positive charge and this is for negative charge, which is R minus. Okay,
so
sir?
2. Yes.
Yes, sir.
Yes, sir.
We are not dealing with this dipole moment right now. This is written for a reference. We'll need it at the end of the derivation. So I can write K and Q common, and what is left inside the bracket is R plus minus, this minus sign I'm writing here, 1 by R minus.
सर पर दोनों माइनस है तो पॉजिटिव नहीं हो जाएगा?
कौन सा नेगेटिव है?
R minus भी तो नेगेटिव ही हुआ.
R minus I'm indicating the distance. I can write this
अच्छा.
R1 and R2. This is R1 and the R2. So minus sign I'm writing as a suffix. This is not minus R. Okay, this would be wrong.
Yes.
Okay.
R minus means distance of negative charge to given point P.
हाँ.
R plus means distance of plus Q.
एक डिस्टेंस इंडिकेट
Distance indicate.
Distance.
Sure, you are clear now?
Yes sir.
Okay. So this will become KQ. If I take LCM, R minus minus R plus
R plus
divided by R plus
plus
R minus.
R minus.
Okay. Now let me take attendance.
सर वो क्वेश्चन का आंसर क्या है? वो गॉड इक्वल टू देवी देवता और देवी देवता इक्वल टू गॉड, वो कल सोच रही थी तो थोड़ा.
Which one?
वो आपने वाइवा में पूछा था ना कि गॉड इक्वल टू देवी देवता या देवी देवता इक्वल टू
हाँ
गॉड,
हाँ हाँ हाँ. So
तो उसका आंसर वो.
हम थोड़ा इसका खत्म करके डिस्कस करते हैं, ठीक है?
ठीक है सर.
ठीक है. ओके ठीक. ओके, हम यहाँ थे, हमारे पास अभी लेस देन 1 मिनट है. हम यहाँ पे ख़त्म करते हैं, थोड़ा आगे सिंप्लीफाई कल करें. संडे है कल. हेलो.
Okay, sir.
हाँ
Yes,
सर.
sir.
Are you all okay with that? So tomorrow
यस सर, संडे
Yes, sir.
मतलब जल्दी, मतलब
invitation
सर
जल्दी
10
भेजो.
बजे कीजिए सर.
हाँ?
सर 10
No.
बजे कीजिए.
इन्विटेशन रात में ही दे देना.
ठीक है, इनविटेशन
No,
रात को
रात
भेजो.
में मत दीजिए सर, सुबह ही कीजिए. सुबह हम लोग फ्री रहते हैं ना, तो
Oh,
10
नो
बजे
नो
कर दीजिए.
नो सर.
तो 9
No,
o'clock
no,
ही
no,
will be
sir.
fine, sir.
ओके.
सर टेस्ट है और लेक्चर भी है.
तो
तो
रिकॉर्डिंग
9
देख
o'clock.
रिकॉर्डिंग देख लेना.
वो तो सर वीडियो रिकॉर्डिंग रखेंगे ही ना.
हाँ.
हाँ सर.
अच्छा भाई लेक्चर अटेंड कर क्यों रहा है? वीडियो रिकॉर्डिंग देखनी है तो.
वो